For generations, the Malaysian state of Sabah carried a comforting title, the land below the wind. Looking at this 3D globe's equatorial band, the Earth's rotation generates almost zero Coriolis force, the spin required for a cyclone. Because physics makes cyclones rare here, normalization bias took hold. The population assumed this geography provided a permanent shield against severe weather. On December 26, 1996, that shield failed. Tropical storm Greg made direct landfall over northern Sabah, bringing sustained winds of 85 kilometers per hour and intense rainfall. By the time the skies cleared, 238 people were dead, 102 were missing, and the region faced over $280 million in damages. This disaster required a very specific sequence of atmospheric anomalies, treacherous geography, and human vulnerability to bypass the equator's natural defenses. The genesis of the storm began in late December. A highly active phase of the Madden-Julian Oscillation, a massive eastward-moving band of rain and clouds, collided directly with a strong surge in the northeast monsoon. As this vector map shows, the collision of these two wind systems forced a localized pocket of rotation over the South China Sea. This interaction artificially generated the atmospheric spin that the weak equatorial Coriolis force couldn't provide on its own. Organizing on Christmas Eve, this system tracked east-southeast at an unusually low latitude, intensifying into a named tropical storm. Between 3 and 4 a.m. on December 26th, Greg slammed into Sabah's western and northern coastline, putting it on a direct collision course with the mountainous Crocker Range. In this cross-section, topography acts as a massive physical ramp. This orographic lift forced moisture-laden air upward, rapidly cooling and condensing it into a localized deluge, pouring an overwhelming volume of water into inland river valleys. The steep mountains intercepted a coastal wind event and concentrated its moisture into a highly destructive water bomb. This aerial view shows the Sungai Pompong River Basin in Keningau. Situated below the mountains, this lush valley sustained the highest concentration of casualties. Along the floodplains and active gravel bars of this river, hundreds of local families and migrant workers lived in unregulated, informal settlement housing. When heavy rains hit at 3 a.m., total darkness obscured any visual indicators of rising water, delaying reaction times until it was too late to evacuate. A violent flash flood tore down the valley. The rushing water carried uprooted trees and thick mud, sweeping away 9 entire villages as residents slept. In the immediate aftermath, search and rescue teams faced total geographical isolation. Landslides and washed-away bridges severed all primary roads connecting Keningau to the outside world, forcing emergency responders to rely entirely on tactical military airlift for both team insertion and critical casualty evacuation. Despite the broken supply lines, local organizations like the Malaysian Red Crescent Society mounted a rapid civilian response. Within the first 48 hours, they established mass feeding operations and impromptu shelters for over 3,000 displaced victims. High-risk residential development in active floodplains, compounded by the complete collapse of land-based transport, ensured a high mortality rate. In the wake of the disaster, state authorities implemented strict riparian buffer zones along major Sabah rivers, legally banning any future residential construction within designated high-risk floodways. The national government modernized its meteorological infrastructure. As seen here, upgraded radar tracking and satellite monitoring networks were installed to issue faster low-latitude cyclone alerts, while the emergency chain of command was streamlined under a framework known as Directive No. 20. The question remains whether this devastating storm was a rare anomaly or an early indicator of shifting climatic conditions. Looking at this heat map, you can track how rising sea surface temperatures are pushing critical thermal thresholds. Waters warmer than 26.5 degrees Celsius, further south toward the equator. This excess thermal energy provides the fuel required for intense low-latitude systems to form more frequently. Surviving these events requires individual action. If you live near a river, maintaining a 72-hour evacuation go-bag is critical, as is recognizing early environmental cues like suddenly muddy water or a roaring sound from upstream. The physical force of moving water is highly deceptive. Just 15 centimeters of fast-moving water can knock an adult off their feet, and 50 centimeters is enough to float most passenger vehicles completely off the road. The geographic position of the equator no longer guarantees immunity. The most effective shield against a warming climate is abandoning the assumption of safety and adopting active preparedness. Stay informed, stay prepared, and thank you for watching. Brought to you by Marufish.